Hello, folks. We are into Math Connections 13-4, 1 to 2, 6 to 7, 11, and 14. I know some of you are going to be sad because there's only 6 of them, but let's take a look. Okay. Tennis balls are tightly packed. How would you estimate the surface area of the balls and compare it to the surface area of the can? So remember, the can is a cylinder. We had a question similar to this about something about the circumference of the ball, of the circle, if you will, and the height of the can. So again, there are 3 balls stacked inside. So you need to find the surface area, compare it to the surface area of the can. Now, the idea here is that you'll actually use what you found before. The height of the can be thought of as a measurement related to the balls, as we know that each ball has the same radius. Okay. Now, the first one does say estimate. The second one says actually go through and calculate it. So estimate how the surface area compares to the lateral surface area of the can. So you can say, hey, I think it's going to be most of this, more than this, less than this. I think it's going to be approximately this much, and then actually go through and compute it. Okay. All right. What else do we have? 1 to 2. Okay, so number 2, which has the greater effect on surface area of a right circular cylinder? Remember those formulas: doubling the radius or doubling the height. Okay, which is going to have a better effect, a greater effect on the surface area? Okay, use the formula. My recommendation once again is to put in 2 times the radius, see what you come up with. Start again at the beginning, put in 2 times the height, see what you come up with, and compare those 2 results. Okay, both of them are going to increase the surface area. Don't say that. Oh, they increase it. They both increase. Of course they do. But you don't have to do all of those. Let's see here. Next up is 6 and 7. So 6 is the total surface area of the following stand, which was cut from a right circular cone. So this is cut from a right circular cone. You know some of these pieces. My recommendation for this one is to treat this like it is just an extension up here. And what you end up with is similar triangles. Okay. Top small triangle is going to be similar to the whole great big triangle. Now you know the radius here, you know the radius here, so that gives you your ratio of sides. If this is 40, how big does that one up there have to be? And the reason why you need that is you're going to do big lateral surface area minus small lateral surface area. So you're going to find the lateral surface area of this entire big cone, the cone that doesn't even exist, and then you're going to go back and find the surface area of just the top piece, because that's what you're going to cut off. When you're done, that will give you this lateral surface area. And the reason that's the biggest thing you need to find is the other 2 are just finding the areas of 2 circles and adding them on. So that's not too bad. Number 7, the sector here is rolled into a cone so that the dashed edges touch. If you need to cut this out of paper, do so. Don't make it 2 meters, though. That's huge. It's like more than 6 feet. So instead, maybe make it like 3 inches or 4 inches. And when you make these cuts into the middle, make them very precise. And then what you should be able to do is take this point. Oops, bad color there. Take this point right over here and just kind of put your finger on the other side. And as you pull this point to touch over there, what will be kind of where the angle was being made comes up out of the page and forms a and forms the apex of the cone. Let's see if I can find a sheet of paper here real quick and do this. So if I were doing it, I would use my compass to make a circle. I am doing one very quickly here, so I'm not going to use my compass to make a circle. I'm going to do my best to make a circular type shape just so you can kind of see how this is done. Okay, so I have a circular type shape. I cut a wedge out of the middle. Now it looks kind of like Pac-Man. Here, maybe I'll stop sharing just for a second so you can see it a little bit better. Kind of looks like a Pac-Man. So if it was laying flat, what they're saying is take this point and bring it so that it touches this other point. So when you do bring those together, I'm going to try to hold them right here. If you look at the shape that's made, it is a cone. I know it's harder to see that way, so there, I'll hold it that way. Right next to the Mandalorian. This is the way. So there it is. If I unfold it, it looks more like just a circle. When I bring it together, it looks like the cone. Let's see what that looks like. Did they give us all the information we need? Aha! And they kind of did, although they didn't tell you they gave you all the information you need. And that is because when you take a look, it looks like all you're given is the radius originally. And that radius, when you make that cone, right, becomes the slant height. So now what we need is, if I want to find a slant height is good, right? Because I need a one base plus 1/2 perimeter times the length. So that means I need the perimeter of this base, and it's a circle. So what's great is that circle base you can think of coming from this shape. And this shape right here is forming an arc length. An arc length we talked about earlier in a prior section. So if you know the angle for your arc length is 240 degrees, and you know the radius right here is 2 meters, you could determine this length because that arc length becomes the circumference of your new circle. One step at a time. All right, what was it now? 6 to 7, so I did 6 and 7, and then it says 11. Let's check over here. 11 and 14, I think. Okay. Student wonders, if you triple each measurement of a cereal box, will you need 3 times as much cardboard to make the new box? What do you think? If you triple each measurement of a cereal box, she says we need 3 times as much. Your goal is to show this student whether they are correct or incorrect. What are they missing? What are they getting right? 14. If you double each dimension of a rectangular box, will it take twice as much wrapping paper to wrap it? Again, very similar. One was tripling measurements, one is doubling measurements. There is a nice connection to be found here. And I think if you've got this, you should be good to go. Yeah, I think that's about it. Phew. That should do it. That's it for the MCs. Hope you have a good rest of your day. Let me know if you have questions. All right, off you go.